In this illustration, we are going to study about non-uniformly charged rod. Here the situation is given as a rod of length L is placed along x-axis as shown in figure, and the charge parent length on rod varies with the distance x from origin as lambda is Cx coulomb per meter. And we are required to find the electric field strength at a point P which is located at 0, L. That is at a distance L from origin along y-axis. In this situation, as we already studied for the rod, if we wish to find the electric field at P, we consider a small element at a distance x from origin which is of width dx. And for this element, the charge dq can be given as lambda dx, which is cx dx, as the charge parent length is varying with distance x. So in this situation, due to this element dq, if we calculate the electric field, it will be in a direction away from this element, which can be taken as dE. So here we can write electric field due to element at point P is this dE can be given by the result of a point charge, which is k dq, that is cx dx divided by the distance square, and this distance here is root of x square plus l square. So this will be x square plus l square. So if we wish to calculate the electric field due to the whole rod, we need to integrate it for x within limits from 0 to L. And here, if this angle is taken as theta, field will have two components. One is d sine theta and other is d cos theta. So here we can directly write at point P, electric field in x direction is, this electric field at point P in x direction we can write as integration of dE sine theta. So we substitute the values. The value of d is k cx dx by x square plus l square multiplied by sine theta. In this triangle, the value of sine theta we can write as x by root of x square plus l square. And we integrate it from 0 to L. So this is giving us here k and c are constants. So kc, where k we can also replace by 1 by 4 pi epsilon naught. Integration of x square dx by x square plus l square within limits from 0 to L. This I'm leaving as an exercise for you to calculate this. You can calculate. It is just a simple integration. We have done it several times. Similarly, we can find out at point P, electric field in y direction is, this is EPY, and that can be given as integration of dE cos theta. And here this can be given as integration of dE is k cx dx by x square plus l square. And in this triangle cos theta we can write as L by root of x square plus l square. And we integrate it from 0 to L. So here also we can take k and c common out. So this L is also a constant that can be taken out. So the CL by 4 pi epsilon naught, integration from 0 to L, this x dx by x square plus l square to power 3 by 2. Here also this should have a power 3 by 2. And finally, this integration you can easily calculate, which again I'm leaving as an exercise. And once you get the value of EPX and EPY here, you can directly write net electric field at point P due to rod is, this EP we can write as root of EPX square plus EPY square that can be obtained. And that will be the result for this problem.